Hi guys, in today's session we are going to apply the basics of integration to the calculation of area of triangle. We are going to take a simple example of a triangle along with its vertices and try to calculate its area using integration. Let me take a simple triangle with its vertices. Find the area of a triangle with vertices 3 comma 6, that is the first vertex. The other one is 8 comma 16 and the third one is 14 comma 10. This is our question. We need to find the area of this triangle. So first of all, let me try and draw the triangle on the graph, a rough diagram. This is our xy axis. Let us roughly draw the points. The first point is 3 comma 6. Let me say this is 3 comma 6. The other point is 8 comma 16. Let this point be 8 comma 16 and the other point is 14 comma 10. Let this point be somewhere over here, 14 comma 10. Let us join these vertices to construct a triangle. The first side of the triangle. Let us draw the second side of the triangle. And then the third side of the triangle. Now, using integration, we need to calculate the area of this triangle. Let us name the vertices first. Let the first vertex be P, the second vertex be Q, and the third vertex be R. As we have seen in the basics video, how to calculate the area under a curve using integration, that was a is equal to integration of y dx from its lower bound to upper bound. Here let us first calculate on the area under the line segment PQ. PQ is one of the sides of the triangle. So what we will do over here is we will draw the area under PQ. This is our PQ. I'll just drop down and let us shade this area. Let me shade the area with green pen. This will be our area A1. Now this area A1 is under the line segment PQ. So how to calculate it using integration? So let me first say that this is our area A1. The formula for area A1 using integration would be integration y dx. And what are the x coordinate limits? You can see this is the first x coordinate and this is the second x coordinate, lower bound and the upper bound. You can see the x coordinate is 3 over here and over here it is 8. So I would say it is from 3 to 8. But the question is, what is this y? Now for that I will have to determine the equation of the line segment PQ, which can be determined by using 2-point form of the equation of the line. Okay, so equation of line PQ by 2-point form would be y minus 16 upon 16 minus 6, which is equal to x minus 8 upon 8 minus 3. After solving this, we are getting y minus 16 upon 10 is equal to x minus 8 upon 5. We get y is equal to 2x. This is the equation of our line segment PQ. So for line segment PQ, our y is nothing but 2x. In short, we have to integrate 2x from the coordinates 3 to 8. So a1 will be equal to integration from 3 to 8 for 2x dx. So simply the integration is x square from 3 to 8, which will be 64 minus 9 is equal to 55 square units. Now, let us concentrate on the line segment QR. Let us first shade the area under QR. So for that, I will use a red pen. First, let us drop down from R. Now, let us shade area under QR. We will name this area as A2. Let us name this as well, area as A2. Now, similarly, for calculation of A2, we require the equation of QR. So let us first calculate the equation of line QR. That will also be calculated using 2-point form. So I will say y minus 16 upon 16 minus 10 is equal to x minus 8 upon 8 minus 14, which will be y minus 16 upon 6 is equal to x minus 8 upon minus 6, which is equal to y is equal to minus x plus 24. That is the equation of line QR. Now, what is A2? A2 is simply integration of y dx. But what are its lower bound and upper bound? You can say we are moving from Q to R. So this is the area which we need to calculate. The lower bound and the upper bound is this. For the lower bound, the x coordinate is 8, and for the upper bound, the x coordinate is 14. So it will be integrated from 8 to 14. So it will be 8 to 14 minus x plus 24 dx. Let us integrate this. What will it be? Minus x square by 2 plus 24x and the boundaries 8 to 14. Now, let us substitute these boundaries. So, first of all, I will say minus 14 square upon 2 plus 24 into 14 minus 8 square upon 2 plus 24 into 8. So, this will be minus 196 upon 2, which will be equal to minus 98 plus 24 into 14, which is nothing but 336 minus 64 upon 2, which is equal to minus 32 plus 24 into 8, which is 192. After solving this, we get the area as 878 square units. So we have also got the area A2. Now if you observe carefully, what is the addition of area A1 and A2? So this total area is A1 plus A2. But we needed to find out the area of the triangle, which is nothing but this particular area. So we notice that this area is extra. Now, this extra area is actually the area under the line segment PR. So, let me shade that with a black pen. Let us shade that with horizontal lining with a black pen, and I will call this area as A3, and note that it is the area under the line segment PR. Let us make a note of this area as well. Area is A3 with black lining. Now, we need to calculate area A3. But for that, we need to find the equation of line segment PR as well. So, equation of line PR. Equation of line PR. That will also be calculated using 2-point form. So, that will be y minus 10 upon 10 minus 6 x minus 14 upon 14 minus 3. So which will be y minus 10 upon 10 minus 6 is 4, x minus 14 upon 14 minus 3 is 11. So after solving this, we get y as 4 upon 11x plus 54 upon 11. This is the equation of line PR. Now what will be area A3? It will be simply integration of y dx. But what are the limits? Let us check. The limits are from 3 to 14. So let me write down 3 to 14. But what is y for line PR? So it is 4 upon 11x plus 54 upon 11. So let us integrate that. 3 to 14, 4 upon 11x plus 54 upon 11 dx. What will be the integration? It will be simply 2 upon 11x square plus 54 upon 11x. It will be integrated from 3 to 14. Is equal to 2 upon 11 14 square minus 3 square plus 54 upon 11 14 minus 3, which we get as 2 upon 11 into 187 plus 54 upon 11 into 11, which after solving we get as 88 square units. Now observe carefully. The total area A1 plus A2 is this particular area. But if I subtract the area A3 from that, I will get the area of triangle. So I would say area of triangle PQR is nothing but A1 plus A2 minus A3, which is quite evident from the figure which we have drawn. What is A1? It is 55. What is A2? It is 78. And what is A3? It is 88. So you would see 78 minus 88 is minus 10. So it will be 55 minus 10. So the area of triangle PQR is actually 45 square units. Now we have calculated the area of triangle PQR using the basic concept of integration. Now we will realize the same concept on the graph paper. So we have drawn the triangle PQR along with its vertices. Let us consider the line segment PR to be the base of the triangle. We will have to measure the length of the base PR. So let us use a scale for that. As we can see clearly that the length of line segment PR is exactly 11.7 centimeter. So let us write down length of line segment PR to be 11.7 centimeter. Now we need to drop the height from the opposite vertex, which is Q, on the line segment PR, which is the base of the triangle. So let us drop it. As we all know, the procedure for making the perpendicular, we can see the arc is going outside the triangle, so we will have to extend the line segment PR for that purpose. So let us just extend line segment PR. Let us just extend line segment PR. So here we have extended line segment PR. Now let us drop the perpendicular. Let us drop the perpendicular. Let us join. This is our perpendicular, which is the height of the triangle. Let us say this is QS. Now we need to measure the length of the line segment QS, which is the height of the triangle. Let us measure it. As we can see from the figure that it is coming out to be, let me mark it very carefully. As we can see from the figure that it is coming out to be exactly 7.7 centimeter. So length of QS is equal to 7.7 centimeter. Now what is the formula for area of triangle PQR? It is simply half into base into height. Now half into base. What is the base? It is PR, which is 11.7, and what is height? It is QS, which is 7.7. So when we multiply these three numbers, we get 45.04 centimeter square or square units. So we have seen that by calculation of area of triangle through the process of integration, we got the answer to be 45 square units, and by actual calculation by using the graph, we got the answer to be 45.04 centimeter square, which is an approximately exact match.